Hello. Today I'm going to be porting a .NET Framework WPF app to .NET Core 3. Now this video will be a little longer than normal for me because I want to show the entire porting process start to finish. So I'm actually going to split it up, and what you're watching now will be the first part of a 5-video series in which we do the end-to-end migration of a WPF application to .NET Core. We recently had a blog post and Channel 9 video where one of our .NET PMs, Olia, ported a simple WinForms app to .NET Core. So this is going to be kind of similar to that. Some of the techniques will be the same. But I wanted to do this video also because by splitting it up and spending an hour or two on it, I think we can see a more complex example. And this way we get to see a WPF app as opposed to the WinForms one, which Olia ported. So the migration process that we're going to go through during these videos is 4 steps. The first step, which we're covering in this video, is all about getting ready to port. It's about understanding the dependencies the project has so that we know what work we have ahead of us, and getting the existing .NET Framework project into a state that will make it easy to port in the subsequent steps. The second step is actually migrating the project file itself. .NET Core projects use the new SDK-style CSproj file format, so you need to either create a new project file for your .NET Core port, or you need to update the existing CSproj file to use the SDK style. The third step is what people often think of when they think about porting to .NET Core, which is making the code-level fixes to get it building against the .NET Core target. So that would be, API level differences that need addressed either because of changes in the .NET Framework or in third-party packages you use. Because we're using WCF here, we're going to have to regenerate our WCF client, and so on. So it's all about those sort of code level fix-up. And this will actually be 2 videos. This will be videos 3 and 4 since it's the lion's share of the work. And then the final step is running and testing the application. People sometimes think that once it builds, you're done, but there are a number of differences between .NET Framework and .NET Core that don't show up until runtime. So you really do need to make sure that you've tested the app, you've exercised its interesting code paths on .NET Core, and make sure that it runs well. So that will be our 5th and final video. So the app that we're porting is, like I said, it's a step up from Hello World, but it's still fairly simple. It's not especially large. But I wanted to make it interesting by using some dependencies that might be non-trivial to port and that are common in real-world WPF applications. So this app is a commodity trading application. I call it Bean Trader. You trade imaginary beans with other users. And it communicates with a backend service using WCF. It has a duplex NetTCP binding. And so it's got that WCF dependency. It also uses some third-party UI controls from MAAPS Metro, uses dependency injection from Castle Windsor, and a whole variety of .NET APIs that are common in WPF apps, like getting settings from an app config file or the registry, using a variety of resources, and so on. The app is up on GitHub, so you can go check it out if you want at github.com/mjrusso/beantrader. You will find the WPF app in the BeanTrader client folder. BeanTrader server has that backend WCF service, which you can just run locally. I have it hosted up in Azure right now. And so you can check this out for yourself. I've got some notes on how the migration should be done. And actually, if you take a look at the branches, there's a .NET Core branch, which has the final state already ported to .NET Core and .NET Framework. So you can find the final ported product in the .NET Core branch. NetFX and master right now are the same. They have the initial state of the project. And migration process is a branch where I'm going to commit after each of the videos I record so that you can see the state of the project as it progresses through the migration process. Also, I do want to mention that this WPF app is not meant to be used as a WPS best practice sample or anything. It's not a reference app for WPF. That's both because I'm not a WPF expert and because I intentionally did some things in sort of roundabout ways in this application to make the porting a little bit more interesting. This is all about the migration process from .NET Framework to .NET Core, not about showcasing the right ways to do things in WPF. Just a quick warning. So let me briefly demo this app for you, and then we'll go ahead and port it. And I'm not going to spend a long time on the demo because the app itself is not the interesting part. It's the way we make it work on Core. But if we run it, you see we've got this Bean Trader UI. It's styled with my app's themes and accents. And I can log in, and it shows me how many beans I have, and it shows me trades that people have proposed. I will also start up a second instance of this app so that we can sort of see how in real time things are updated. Let's log in here as a different user, maybe as Daniel. And then here I can see, okay, Daniel will give me 20 red beans for 10 blue and 5 greens. If I accept it, you can see that both users are notified, bean counts are updated, and so on. Then maybe I can make now I've got a lot of blue beans, so maybe I want to give 5 blue beans and get, I don't know, 5 green beans. And then that shows up for both users as well. So that's the application. Nothing fancy, but it's hopefully a little bit more real world than just, you know, saying hello on the screen, because we're using a WCF client, we're using app configuration, we're using my apps, Metro, dialogues, and so on. So let's go ahead and port this. The first step, like I said, is that we want to prepare and understand the work that we have ahead of us. And so we're going to look at our dependencies. We're going to look at third-party dependencies, and we're going to look at .NET dependencies. For the third-party ones, the first step, if you have a packages.config file, we're going to want to change this because the packages config file lists all of the NuGet packages that our project depends on. And in fact, it lists the sort of transitive closure of all of the NuGet packages. In .NET Core, using the new SDK style project, we no longer use packages.config. Instead, we use the newer package reference format to pull in NuGet dependencies. So one of the things you're going to want to do to get your project ready to port is you're going to want to make that transition. So right-click on packages.config and click Migrate packages.config to package reference if you haven't done this already with your project. And this is going to do two things for us. First, it's going to migrate to the new package reference format so that we can just copy and paste our NuGet references from the old project into the new one, and it'll make that that process super easy in the next video. And it allows us to only reference top-level projects instead of the whole, you know, transitive dependency tree. So the migration tool in Visual Studio is really nice. It identifies the top-level projects, and then we have an opportunity to select any other NuGet packages that are dependent on that we'd like to promote to top-level dependencies. In this case, I don't want to make any of those top-level. And then when we click OK, it makes the changes. It's going to remove our packages.config file, and it will update the CS.proj file to use package reference instead. So we'll let this finish. It generates a little report showing what changed. That's fine. And let's go ahead, we'll save the changes to the project file, and then I'm actually going to open this up in Visual Studio Code so that we can easily see the CS.proj file without having to unload the project in Visual Studio. And you can see that down at the bottom of the project file there's a new item group with these package reference elements. And so this is the replacement for packages.config. And like I said, one of the nice things about this format is that now I'm just looking at the top-level packages. So these are the packages that I need to have present for my project to work and that are going to need to work on .NET Core. So at this point I can review these and make sure that I have a version that's going to work for me when I actually do the .NET Core migration. So if I go out to NuGet.org, we can start looking some of these up and see what our options are. So we have Castle Windsor, for example. And we're using Castle Windsor version 4.1.1, so I'll click on that version. And you can see in dependencies that it has .NET Framework dependencies and .NET Standard 1.6 dependencies. So this package should work as is on .NET Core because .NET Core, of course, can depend on .NET Standard packages as well. Another view you can use instead of NuGet.org, if it's hard for you to tell which .NET targets are supported, you go out to Fugit.org. It's the exact same URL, but replace the N in NuGet with an F. This is a site that some community members made that gives another view into NuGet packages. It gives a little more details as far as what APIs are present, and it specifically lists frameworks up at the top here, so we can see .NET 4.5 and NET Standard 1.6. So this package is fine. We can also look at, say, maapps.metro, and we see that, once it loads here, maapps metro version 2 at least supports .NET Framework and .NET Core 3.0, but we're using version 1.6.5. So if we go back to that, we see, here it doesn't support .NET Core. It only supports .NET Framework. This can be similar if I look up, for example, the Nito Async or the Microsoft Azure Common libraries. All of these support .NET Core or .NET Standard in a more recent version. So here 2.2.1 supports NET Standard 1.4. But some of the older versions that my initial sample depended on don't support .NET Standard. This is going to be common. A lot of older WPF and WinForms applications will be using older versions of NuGet packages that don't support .NET Framework, or .NET Standard or .NET Core, but they have newer versions that do. So that's the second thing you can do to get ready to port. You remember that I said you can get ready to port by migrating to the package reference format for your NuGet packages. The other thing you can do is upgrade to newer versions so that you know when you go to .NET Core you'll be able to use the same NuGet packages you were using previously. Now sometimes that may take a little bit of work. Like if we make a major version change, like from maapps metro 1 to 2, there could be breaking changes. So in some cases, you may not want to actually update because you don't want to make all of the changes to use this new version. But eventually that should be done. And so this is a good time to take care of it if you're able to, because it's going to make the migration a little bit easier. Now, what if you don't find an updated version that references .NET Standard or .NET Core? Or what if you really don't want to move because you don't want to take some change in surface area of newer versions of these packages? It's possible to depend on .NET Framework libraries and NuGet packages from .NET Core applications. And we allow that because the surface areas are so similar nowadays that those sorts of dependencies often work, but they don't always work. And so if you're going to depend on a .NET Framework package, you need to be a little bit cautious about it. You need to keep in mind that that's going to require some extra testing, because what will happen is we'll allow it to build, but at runtime, when you're running on .NET Core, if your .NET Framework DLL or NuGet package that you're depending on calls an API that doesn't exist on .NET Core, that only exists on .NET Framework, you're going to get a runtime error. And so there's an extra test burden if you depend on older .NET Framework packages or libraries. But we allow it because there are some situations where an old NuGet package hasn't been updated in years. It would work fine on .NET Core, it just hasn't been retargeted. So in those cases, we allow you to use those libraries. They work. Just make sure that you test that at runtime you're not going to get a missing method exception or something like that. Okay, so we can go through these individually, but I know that they all either are supported on NET Standard or NET Core or have updated versions that are. And I'm not going to update to the newer versions now. I'll do that in the next video in the interest of keeping this first one short. But that's reviewing your third-party dependencies. The other thing we want to look at is first part, .NET dependencies, like different APIs we're calling from the .NET Framework, to make sure that those same APIs exist in the .NET Core surface area. And for that, we're going to use the .NET Core .NET Portability Analyzer, which is a tool that the .NET team created and maintains that will look at your binaries, find all of the .NET APIs that are called, and then produce a report showing whether those APIs are available on different .NET targets that you care about. The tool works both as a Visual Studio plugin or from the command line. Now, we've talked about this tool a lot in the past, so if you're already familiar with it, you can be done with this video and move on to the next one, because the next 5 or 6 minutes will be review. But for folks who haven't used the tool before, let me show you quickly how it works. Like I said, you can use it from Visual Studio or from the command line. Both work well. I'm going to do it from the command line just because I feel like we demo that less often, and I think it's a great option. So if you run API port, you'll see there's a few different commands you can run. List targets will show all of the .NET targets that you can get information on. List output formats will show the different output formats that we can use. I'll run that quickly. You can get output formatted as HTML, Excel, or JSON. And then the command that we really care about is analyze, which is actually going to do the analysis of our project. So we'll do API port analyze -f give the path to our the binaries that we want analyzed, -r to specify which output formats I want. And I like to do both HTML and Excel because I think they're both useful. The HTML report, in my opinion, is the most human readable and the easiest to get an overall sense of what APIs are present or missing. The Excel report is nice though because of course it's writable. You can put notes in a new column. So if you're reviewing this with a team or working through maybe migrating away from some APIs that aren't available on .NET Core, you can use the Excel spreadsheet to track that, keep notes, and so on. And then we'll do -t to specify the .NET target that we want to use. I'll say .NET Core. And I could specify which version of .NET Core, but by default, all of the targets will pick the latest version, and in this case that's .NET Core 3.0. So I run the tool. It has produced this HTML file as well as the Excel spreadsheet you see. So let's pop this open and see what's in here. At the top we have all of the binaries that were found in that path that I provided and how compatible they are with .NET Core. And you can see these are fairly high numbers, which is nice. But something I want to emphasize is that you shouldn't look too much at this number. It doesn't mean a whole lot. You may have a 85 or 90% here, and that's okay because the APIs that you're depending on are easily worked around, or there are other alternatives that you can use instead. You might have a 98% here and have a big problem because you're using some APIs like creating app domains or remoting APIs that simply aren't supported on .NET Core, so now you have more work ahead of you. This single number doesn't tell you a whole lot. What you really need to look at is to drill into the binaries that you own the source code for. So in this case, that's only this top one, BeanTrader Client. And look at the APIs that are missing, which would be the ones with these red X's here in the .NET Core column. Make sure that for all of those, you have an idea of how to work around them. In this case, the only APIs that are missing from the BeanTrader Client app are some WCF client-based APIs. Close and open are missing. I'm not super worried about these because I know that WCF client APIs are generally supported on .NET Core. Not all WCF client APIs, but a good subsection. And so certainly there are ways to open and close WCF clients. There are probably alternative APIs I can use here, probably async alternatives to these synchronous ones that are no longer present. So this makes me feel pretty good. Now we do have information on our other binaries, but this is not interesting either, because I don't own the source. There's nothing I can do about these ones. Like Castle Windsor. Castle Windsor is missing some system.web APIs that it was using. If this was my code, we'd have to migrate to using like some ASP.NET Core alternatives. And for the logical get data, set data stuff, I would use async locals. But I don't own Castle Windsor. And in fact, remember we looked and we saw that Castle Windsor version 4.1.1 is targets .NET Framework and .NET Standard 1.6. So because it targets .NET Standard 1.6, I have confidence that there is a Castle Windsor binary in that NuGet package that's going to work for me. This particular one that was in my binary output folder that targets .NET Framework, well, maybe it doesn't work, but the Castle Windsor package supports .NET Standard. So there's another binary that will be used that will work. So this one doesn't even really matter. So these other libraries, these other binaries, you need to make sure that there are versions of these that work, but we've already done that by looking through the NuGet package dependencies and other third-party dependencies that our project has, and making sure that there are alternatives there that will work for .NET Core. And so when we look at the API port report, you really only need to look at things that you own and just look at these APIs to make sure there's nothing really crucial here that's going to block you. So at this point, I feel pretty good about porting to .NET Core. We've reviewed our NuGet package dependencies. We've upgraded to use package reference format, which will make the migration easier. And we've looked at an API portability report to make sure that we understand which .NET APIs we're depending on may not be present once we migrate to .NET Core, so that we know that those are things that we can work around. At this point, we're ready to start the migration, which we'll do in video 2.